In this video, I'll walk through an example of solving a differential equation. If dy dx equals 5x squared y and y of 0 equals 6, find an equation for y in terms of x. This is our differential equation. This dy dx equals 5x squared y. And this is our initial condition. So this is our x value. When x is 0, that's our initial condition. Then our output y is 6. This differential equation happens to be solvable by separating the variables, meaning we get all the x variables on one side and all the y variables on the other side. So what I'm going to do is I'm going to divide each side by y. That'll get rid of y on this side, and I'll have 1 over y on the left-hand side. So let's write that. 1 over y times dy equals, now I should still have over dx, but I'm going to multiply each side by dx. So that will get rid of this dx. So multiplying each side by dx leaves us with 5x squared dx. So again, I've divided each side by y and multiplied by dx. And in other words, I did what was necessary to get the y on the left-hand side and the dx on the right-hand side. Now what we're going to do is take the integral of each side. Now depending on your book, they may not show the integral sign when they introduce differential equations. A lot of books do talk about integrals first and then the differential equations. But regardless, this is what we're going to do. This purple thing is called the integration sign. So that's taking the antiderivative. So we think, what do we have to take the derivative of to get 1 over y? Well, that's the natural log. The natural log of y. And taking the derivative of dy just gets us back to 1. So we have natural log of y times 1, or just natural log of y, plus c, because we could have some constant, but I'm just going to save that for just one side. When you have an equation, you can just put the constant on just one side. So the antiderivative of 5x squared is, we know it's going to be x to the third. We increase that exponent by 1 because we're taking the antiderivative, and then take the coefficient and divide it by that new exponent. So you could take the derivative of this to check to see if you still end up with 5x squared. So we took the antiderivative of each side. We also have to say plus c. That's because if we took the derivative of this constant, we would get 0. So it wouldn't show up here on this previous part. So we have to say allow for the possibility of there being a constant there. And we'll find the constant in just a little bit. Okay. We want an equation for y in terms of x. So let's pull a little trick here, and using properties of exponents and logarithms, if natural log of y equals 5/3 x cubed plus c, then it is true that e to the power of each of those equals each other. So now properties of e to the natural log of y, that just equals y. And that's why we did that. The reason we kind of got rid of the natural log by taking the inverse. So e to the natural log of y just equals y. Here we have e to something plus something else. Well, properties of exponents says that that is the same as e to the 5/3 x cubed multiplied by e to the c. So, right, if you multiply like bases, you add the exponents. So we see that the exponents were added, and so we can just kind of go the other way and say we are multiplying like bases, and we've got these exponents attached. This part, this e to the constant, we still don't know what the constant is. So I'm just going to do this. I'm going to say this is some new constant b. Some number e raised to a constant c is some new constant b. And in some books will just leave it as a constant c, or they call it k, but I'll call it b so I don't confuse the issue. So y equals b times e to the 5/3 x cubed. All right, this is what we call the general solution. This is a general solution because we don't know what b is yet. So it's a general solution. But that's okay. We'll go ahead and find what b is because we have this initial condition. So let's plug some stuff in. We know that y is 6. Let's get to a nice color here. Y is 6 when x is 0. So 6 equals b to the e, or b times e to the 5/3 times 0 to the 3rd. Well, that's not too hard to evaluate. Anything to the 0 power is just 1. So we're left with 6 equals b. Now we can plug that in for our particular solution. And I'll write that as y equals 6 times e to the 5/3 x to the 3rd. So this is what we call our particular solution. It's particular to this initial condition. So we found there are a number of good things there. I just want to review that real quickly. They were separable. This equation was separable. We did what we needed to get the y on the left-hand side and the dx on the right-hand side. We had to play this little trick with raising everything, or e to the power of everything that we saw, so that we could get rid of the natural log. And then we had properties of exponents, so that we could further separate. I don't want to confuse that, but get this constant by itself, this unknown constant. So we had our general solution, and then we plugged in what we knew from the initial condition, 6 for y and 0 for x, to solve for the unknown, that was this one, and to make it a particular solution. So there we have it.